All right, this thing's recording, right? Yeah. All right, so ace of base. I saw the sign. I saw the sign. Ladies and gentlemen, today we are going to use the law of sines because you're all like, what do you do, Mr. Gotch, to solve triangles if they're not right triangles, right? What do you do if it's an acute triangle or an obtuse triangle? Well, the first thing I would do is I would try my law of sines. And we use law of sines when I have side angle angle or angle angle side and angle side angle. And on Tuesday, we're going to talk about this one, SSA, because that is the tricky one. It's a real pain in the SSA. Okay? That's what we call the ambiguous case. And you'll see different scenarios where you could actually get two triangles when it's angle side side. It is a real pain in the angle side side. But today we're going to do the easy ones. So side angle angle and angle side angle. So it's going to look like this. And have you guys seen this before? Yeah, you guys are shaking your heads. Yes. Okay. So big thing is make sure you know little a is across from alpha or big A. Big B, beta, is across from little b. And this is gamma or big C if you want to do that. And that's across from little c. Okay. Well, we're going to set up these ratios to solve for little sides and angles. So here we go. Example number one. I have solved the given triangle. I have alpha is 30, beta is 70, and little a is 5. So I know I have, if I draw it out, rough sketch gives me side angle angle or angle angle side, whichever you prefer to say. And now I want to find the missing stuff. Okay. Well, the first thing I want to find is what? What's the easiest thing for us to find? Easy peasy. Grant? Y. Yeah, that little y or gamma. We know that there's 180 degrees in a triangle, and we have two angles, so go ahead and take those two and subtract from 180, and that's going to give me gamma, which is like a fancy y. And gamma's how much? 80 degrees. Boom. So this question was on a quiz or test. I usually like to make these 5 points, and that's an easy point. You should get that automatically. So that's the 1 out of 5. Now to find the other stuff, B and C, we should be able to use our law of sines, and that's going to take 2 points each to get that total of 5. So as I take a look, your choice on you want to find B or C. What do you guys want to do? B? Well, we have to use the information that has an angle and a side across from it. So we have to use 30 and 5. So as I set up, I've got the sine of 30 over 5 is equal to, you said B, and across from B is what angle? 70. Okay, so if you want to find B, you've got to use sine of 70. Okay. Well, now this is a proportion, and proportions are set up nicely for what? A little cross multiplying. So go ahead and cross multiply here. Now, you guys are pretty smart, and I know you are. If you don't want to show all this work, you don't have to. I don't a lot of times. But for notes, I'm going to do it here. So if I multiply b times sine of 30, I got b times sine of 30, and 5 times the sine of 70 is just 5 sine of 70. Well, what's my last step? How do I get the b by itself? Vicki, what do I got to do? Yep, just go ahead and divide by sine of 30. So I get b is whatever this guy is. First thing I always do when I'm doing chapter 8 is I double check to make sure my calculator's in the right mode. So press mode and make sure you guys are in degrees. Okay. So I'm in the right guy here. And now I like to use alpha y equals number 1 or alpha link if you have the new updated calculator. You can do that. But that way it has a nice fraction. So I'll do 5 sine of 70. Close it. And then divided by the sine of 30. I can zoom in just a touch more here. Maybe. Maybe not. Anyway, so I press enter. And there we go. We get about 9.4-ish. Are you guys getting that? You guys have to see what they want. If they want 2 decimal places or 1 decimal place. You got to see what they're looking for. I think on the homework, it's just to the 10th spot. It's just 1 decimal place. So it should be not too bad. Okay. Questions, y'all? Common mistakes if you're using like a TI-83 and you're not using the alpha y equals or alpha link to make that fancy fraction. Sometimes people do this. They'll go 5 sine of 70. Okay. And then they divide by the sine of 30. And then they press enter and they get this. And that's not right. Do you guys see what I did wrong? What did I do wrong? Yeah, I got to close those parentheses, especially for the 70. So if I type that in again, you have to close that parenthesis. They don't really care about the second parenthesis. It's the first one you for sure have to do. Okay? So if you're just typing in like a line like that, close that parenthesis. Okay? Guys good? All right. Well, next, we got to find little c, right? And the question I get is, can I use Pythagoras to do that? What do you guys think? Yes or no? Can I use Pythagorean theorem? I see head shaking no. Why can we not use Pythagorean theorem here? It's not a right triangle, right? So if we had a right triangle, then we just use SOHCAHTOA. But because we don't, because these are all acute angles, 80, 70, and 30, I have to use law signs. Okay? So as I set up, I use that same fraction we had, the sine of 30 over 5. And now we want to find little c. What angle's across from little c? 80. So I got the sine of 80 now. And Jack says this is perfect for what? We got law of sines, and it's a fraction, so it's perfect for cross multiplication. Boom. So we get c times the sine of 30. And again, I'm showing a lot of work here. I don't need to see this much work. And then 5 times the sine of 80. Go ahead and divide by the sine of 30. Go ahead and pluggy-chuggy that in. So again, alpha link is nice, or alpha y equals number 1. And type it in 5 sine of 80 divided by the sine of 30. And I got about 9.84. So the 4 keeps the 8, so I'm going to do 9.8. And those are pretty darn close to each other, right? Well, if you look at the angles that they're across from, 70 and 80, those are pretty close angles. So the sides should be pretty close. Y'all have any questions for number 1? So out of 5 points, I'll give you a point for the angle and 2 points for each side that you find correct. Easy peasy? All right. So that's an example of angle, angle, side, or side, angle, angle. And we flip it on over. We flippy. And now they got example number 2. I got alpha's 20, beta's 60, and I have C is 12. That C, that side, is in between the 2 given angles. So we call this angle, side, angle, where the side is in between the 2 given angles. Well, I could use law of sines to find the angle, or just subtract from 180. Right? So go ahead and find gamma. 180 minus 20 minus 60, and what do y'all get? How much? 1 hundo. Okay. And now we're working through, and now we can find little a and little b. Doesn't matter which one you find first. What do you want to do? Which one? Do B? B. All right, so they gave me 12. So I'm going to use that, and 12 is across from gamma. So I'm going to put a hundo there. So I got the sine of 100 over 12 is now equal, and I heard B, so we're going to do sine of 60 over little b. Again, you can cross multiply and solve. If you're really good and you just want to say, well, I'd take 12 times sine of 60, and b times the sine of 100, and I divide by sine of 100, that's usually what I do, is I'll just go right to that step. Just don't make any silly mistakes on quizzes and tests. You need to write it out. So go ahead and pluggy chuggy that in. I've got 12 sine of 60. Close it. Divide by the sine of a hundo. And I got 10.55. That 5 rounds up to 10.6. Let me know if you're not getting that. Questions, y'all? We got to find little a, so do it one more time. I'm going to use the sine of a hundo over 12. And now across from little a is how many degrees? 20. So use a little sine of 20 over there. So again, cross multiply, I get 12 sine of 20. And then I would divide by the sine of 100. If you want to show that work, you can, or if you want to do what I'm doing, perfect. And alpha y equals number 1 works. Or if you want to type it in just like you see it, just make sure you close parentheses. If you don't close parentheses with the alpha y equals, when you press enter, it actually closes your parentheses for you. So it's kind of sweet. It just does it for you. You don't have to worry about it. 4.16, that 6 rounds up to 4.2. Okay. If C had some units, I would include units here. Like if this was in feet, I'd make sure I'd have feet there. Okay, it's not, so we don't have to. And there we go. Questions, y'all? Applications of this, here we go. The Bermuda Triangle is a region of the Atlantic Ocean between Bermuda, Miami, Florida, and San Juan, Puerto Rico. It is an area where ships and airplanes have been rumored to mysteriously disappear. If the angle formed by Miami is 53 and the angle formed by Bermuda is 59 degrees, what is the distance from Miami to Bermuda? We'll call that X. Call that Y. Miami to San Juan. So take a second, see if you guys can't figure out what X and Y is. So the missing angle you needed from San Juan is 68, right? And what did you guys get from Miami to Bermuda? How far is that? Who got that one? Yep.
1,035.7.
1,035. Is that this one?
Never mind. 1,000 minus 20. That all the way around.
All right, so this is 35.7 miles. And then this one was
1,120.
point how much? 0.3 miles. Okay, and again, the setup for you guys is if I want to find the sine of x, if I want to find x, I got to use the two sides I have, the side 965 and the angle across from it is 53. And if I want to find x, across from that is this angle, which you got to find, subtract the two you know to find the one you don't know. We have the sine of 68. So go ahead and cross multiply here. 965 times the sine of 68. And then divide by the sine of 53. And we should get 1,120.3 miles. So that's what this one is. And the sine of 53 over 965 will help us find y from Miami to San Juan. So the angle across from that is 59. So go ahead and cross multiply. 965 times the sine of 59. And then I would divide by the sine of 53. So we should get 1,035.7 miles there. Okay, good stuff. Make sure you have units. We're again talking about miles. So have your miles there. And we're good to go. Questions, y'all? Questions?